Welcome. Today's lesson is for 8.5, isosceles and equilateral triangles. Let's go ahead and start with the definition of an isosceles triangle. So here's my isosceles triangle, and we learned that an isosceles triangle has two congruent sides. So I'm going to go ahead and mark them. These are called the legs. These are called the legs. And I wrote that really fancy, so underneath here, I'll go ahead and just write that that is the leg for you. Okay, so these are the legs. And then the third side, the non-congruent side, is called my base. Now, be careful because that is a very misleading term. A lot of the times we think of the base as being what the triangle sits on. And that's not the case. I can take this triangle and I can rotate it for you. The base in this case is just the non-congruent side, the side that's different from the other two. Since my triangle has three angles, this angle at the top between the two congruent sides is called my vertex angle. This is my vertex angle. And remember, the symbol for angle looks like the less than symbol. So I'm just going to go ahead and write that for you. And that would be, of course, this one right here. Okay. My other two angles, there's a property that there's a theorem that you're going to see next that says they are the same. So these are my two angles, and they are going to be the same, and they are called my base angles. They are called my base angles, and they will always be the same. Notice that the base angles always touch the base and one of the legs. So as you look at them, they always touch the base and then one of the legs, the base and one of the legs. The vertex angle only touches the leg and the leg. So the vertex touches the leg and the leg, the two congruent sides. Okay, this is my isosceles triangle. Let's go ahead and talk about those two theorems. So there's a theorem called the base angle theorems, which says if you know that two sides of a triangle are congruent, so if you know your triangle is isosceles, then the angles opposite them are congruent to. Ooh, that should say congruent. Let me go ahead and add that to it, are congruent to. Okay, so what that means is I can grab my side and shoot across this angle is equal to that angle. That's what they're talking about, the opposite. That's what they're talking about, the opposite. So they're saying these two angles are given. What this theorem says is I only have to mark the sides, but then I can ask you about those peach angles. Okay, and that's what you're going to see when you look at the assignment. The sides are marked as isosceles, but I'm asking you to solve, and I'm putting the expressions at the angles. The converse of this is also true, which says if I know that two angles in a triangle are congruent, then the sides opposite them, here and here, are congruent as well. So basically, then you know that this triangle is an isosceles triangle as well. What this is doing is basically it's saying that I'm giving you an isosceles, and what I'm doing is I'm either going to give you the sides as equal and ask you about the angle to solve for x with the angles, or I'm going to tell you that the angles are congruent and ask you to solve for the sides. Okay? All right, I have an example to take a look at these, and here it is. So notice this one looks like the converse. This one looks like the converse because I can see already that angle B and C are equal. So I can go ahead and say that this side and this side are equal as well per the converse of the base angles theorem. This one looks just like it. So now I can go ahead and since I marked those two sides as equal to solve for x, I simply set them equal to each other. That's all I have to do. Okay? Remember, you can always draw your line if you need it, and you just solve for x. That's all you have to do. So let me go ahead and do that for you. Move the x first, then you want to add the 20, which gives you 3x equals 21. divide by 3, x equals 7. There would be the answer that I would put in. Okay. The only other thing that you could be asked to do is to plug it in. 4 times 7 minus 20, what is that? 7 plus 1, what is that? That's 8. Okay. All right, let's take a look at another one. In example 2, we are asked to find the value of x and y. Notice that I know I have a isosceles triangle. Per the base angle theorem, since those two sides are congruent, this angle and this angle are my base angles, and I know that they are congruent as well. Okay, so let me grab this. This is congruent to that, and this is my vertex angle. This is my vertex angle. Okay, so what I'm going to go ahead and do is I'm going to use the base angle theorem, which says I can take my two peach angles, 3x minus 11, and I can set them equal to each other, 2x plus 11. So I can go ahead and set them equal to one another. And now I just go ahead, draw my line, and solve for x. Move one of your x's first. I like to move the smaller x, but that's just a preference. Remember, technically it is 1x, but I don't have to write the 1 because it can be invisible. It doesn't have to actually be there. All right, so there we go. I got x equals 22. Now, to find the vertex angle, I have to use my triangle sum theorem, which means that I know that the three angles in my triangle, the two peach and the green, need to add up to 180 degrees. So the first thing I'm going to do is I'm going to plug my 22 into my picture. So I'm going to say 3 times 22 minus 11 equals what? And I plug that in my calculator and I get 55 degrees. Now I know that the other one is also 55 because I have marked them as equal. That's what these peach marks mean. But if you're not sure, you can always plug it in. 22 times 2 plus 11, and you do get 55. All right, so what I know is that 55 plus 55 plus 2y has to be 180 because that's what the triangle sum theorem says. The three angles of my triangle must add up to 180. I'm going to just go ahead and combine my like terms. So 55 and 55 is 110. There we go, give myself a little bit more space. I'm going to subtract my 110, right? Because remember, I'm just solving my equation. That should give me 70. Yep, and I divide by 2. Y equals 35. There's nothing else I can really do. I guess they could ask me to do what is the value of the vertex angle 2 times 35. They could have asked me for these ones as well. All right, let's talk about the equilateral triangle. And as you can see down on the bottom, these are the rules, and they're just converses of each other on the left and the right side. So basically this says if I know my triangle is equilateral, then it is also equiangular. So what that means is I could just put the green marks and then ask you about the angles, the peach marks. Okay, the converse is true as well. Remember, the converse just switches the the green with the peach. So if I know a triangle is angular, all the angles are equal, then that automatically means all my sides are equal as well. Okay, which means I could mark the angles as equal and then put the expression on the side. Okay, put the expression on the side. If my triangles are equiangular, if I am equiangular, a triangle adds up to 180. And if all three of them are equal, each one of them has to be 60 degrees. So each one of those pink angles needs to be 60 degrees because 60 plus 60 plus 60 is the only way I can get 180. All right, I have only one example for you of my equiangular triangle. And as you can see, I have showed you that it is equilateral, which means I also know it is equiangular. So I could go ahead and say, I know all these angles are the same. I also know that 180 divided by 3, each one of them is 60 degrees. Okay, so what this means is I'm going to take that 4x minus 8 and I'm going to set it equal to 60. And then I'm simply just going to solve this equation. Add my 8 and divide by my 4. X equals 17. Now, the only other thing I could be asked to do is to go back and to plug this in. What is 4 times 17 minus 8? More than likely not, because I already know the answer to that question. It better be 60. All right, I do want to quickly, that concludes the lesson. I just want to quickly show you what your assignment on Alex is going to look like since I'm not going to be there today. So you have 4 questions. And question 1 and 2 look the same, and then question 3 and 4 look the same. So here's question 1 and 2. They're simply going to ask for each part below, use the figure to fill in the blank. If necessary, you may learn what the markings on the figure indicate. So I think that just means you could click this and then Alex would tell you what that means. I think they're talking about this, but that's what I'm guessing that is for. So the first question is asking me to find AB. It wants to know how long this is. So I'm going to use my highlighter, I think. Use my highlighter to help me out. They want to know how long that side is. So what I see right off the bat is that all my angles are 60 degrees. This is an equilateral triangle. If all the angles are the same, then all the sides are the same. And so since one of them is marked as 12, my answer is simply 12. My second triangle, I can see is an isosceles triangle because there are my legs and here is my base at the bottom. Just for reminders, that means these two angles are the same and that this angle here at E is my vertex angle. This would be my vertex angle. Okay, it's very important when they're giving you an angle that you identify it. Okay, is it the vertex or is it the base? I'm going to go ahead and take my 180 because all 3 angles in a triangle have to add up to 180. And I'm simply going to take away the 130 that I was given. So if you were given a different number in this same position, you would take it away. Okay, so 180 minus 130, I think that's 50. No, I'm going to double check. Yep, 50. Okay, now that does not mean that 50 is your answer. That means that D and E together are 50. Since I know that they are the same, I'm going to take my 50 and I'm going to divide by 2, and they are each 25 degrees. So this is the answer that I'm going to put in the blank. Question number 2 is going to have you do some of the same stuff. It's going to have you do some of the same stuff. So for A, they're going to ask me for angle K. I can already see that 10 and 10 are the same. This is an isosceles triangle. This is my vertex angle. This is my vertex angle because remember my vertex is always between my 2 legs. So since those are the 2 that are the same, this is the one that is the vertex. And then these angles down here are my base angles and they are equal to each other. So notice what they're doing. They're telling me that one angle is 70, but there's also a second one. So for this one, I'm going to do 70 plus 70, which is 140. And then to find that angle K, that vertex angle, I'm going to take the 180 of a triangle which is the measure of a triangle, and I'm going to subtract the 140, which gives me 40 degrees for my vertex angle. Looking at B in question number 2, for me, I can see that all the angles are marked the same. If all the angles are the same, then all the sides are the same. So if they want HI, there's HI, right? That's the one they asked for. This one over here is 3, so they're all 3. There would be my answer. Okay. Questions 3 and 4 are going to ask you about the isosceles triangle, or maybe about the no, I think it's all isosceles. And if you notice right here, it says that it has a base of ED. So it's already telling you that this is the base. The purpose for that is so that you can say this angle and this angle are the base angles. They have to be the same. And then this angle is my vertex angle. So this one is my vertex. Okay. I'm going to use the fact that they add up to 180, but notice what they're doing. They're only giving me E, but in fact, D is the same. So this is also 5x plus 8. It's the same. So I'm going to go ahead and say 5x plus 8 plus 5x plus 8, my two base angles, plus my vertex angle, 2x plus 56 equals 180. And I'm going to go ahead and combine my like terms. So I'm going to use my same colors here just to help me combine my like terms. So 5x plus 5x, that's 10x, plus 2x, that would give me 12x. And then 8, it's positive, plus 8, that's 16. 8 plus 8 plus 56, 72. So plus 72 equals 180. And now I'm just going to go ahead and solve. So let me subtract my 72 from my 180. 108. I'm going to go ahead and divide that by 12. X equals 9. They are asking me right here the degree of each angle. So to find each one, I'm simply going to go back and I'm going to plug it in. So for angle C, it's 2 times 9 plus 56. 2 times 9 plus 56. I'm going to use my calculator. I got 74. For angle D, I'm going to go ahead. For angle D and E, because they're the same, I'm going to do 5 times 9 plus 8. 5 times 9 plus 8, 53. And I'm going to put that for both of them because they should be the same. Okay, I'm just going to check something really quick. Yeah, I'm good. Okay, question number 4 is the exact same thing. I'm just going to do it super duper fast for you guys. But once again, they're letting me know that I do have an isosceles triangle and that FE is the base. They're letting me know that because then I know that these are the two equal angles and this is my vertex angle. This one, I actually don't have to use 180. These marks here in the peach mean that these two are equal to each other. So all I have to do is say 3x plus 23 equals 2x plus 36. And that's how I'm going to find x. So I'm going to subtract my 2x because I always like to move the smaller one first. That would give me just x, which remember can be considered as invisible, minus 23, minus 23, and 36 minus 23 is 13. I have to go back and plug it in. I have to go back and plug it in. And I'm going to start at the bottom with angle F, which is also angle E. Oh no, they're different this time. Never mind. They're different this time. Let's start with angle F. So 3 times 13 plus 23. So 3 times 13 plus 23, I'm using my calculator, 62. So I'm starting at the bottom. Angle E, 2 times 13 plus 36. 2 times 13 plus 36, 62. And that should happen because we already said that they were equal, right? We said it here and we said it here. So we should have come up with the same thing. Now, how do I find angle D? Because I have nothing to plug it back into, right? I have nothing to plug it into. I simply take 62 and I add 62 to it. 62 plus 62, 124. Then I say, well, a triangle is 180, so let's just subtract that 124 from it, and we get 56, which is angle D. All right, I hope this helps. If you guys have any questions, feel free to send me a message. You can send it through Remind, or you can send it through Schoology, or you could just email me. Have a great weekend, and we'll see you on Tuesday for A Day and Wednesday for B Day.